Now, if you weren't here, for those of you that I know were not here, left off in the last video talking about observations of the pendulum. I don't know, I pointed at my screen, but you're looking at the, yeah. Anyway, the orange here is what we had originally for observations. And then when we came back together yesterday, no one really had anything else to add to the observations. So I put this information up. These right here, filter questions, I called them. There's two things we have to, when we observe a phenomenon of nature, which is what a pendulum is. I mean, it's a phenomenon of nature. We have to filter those observations through these two questions. Number one, can we measure it easily? So is what we've observed something that we can measure easily? Now, I put the word easily in there because there's all kinds of things that can be measured that we don't necessarily have the equipment or tools to be able to measure. So it's not just can it be measured, but can it be measured easily, that we could actually do it ourselves. That's number one. Number two is, can we change it without breaking something? Is this something that can change? We can alter it without actually breaking something. So we started looking at our list in that way. And we said that it swings back and forth. Well, this is true. And then so the question is, can we measure that? Like there's something we can measure about that. Well, then someone suggested, well, we can measure how far it goes back and forth. And I told them, hey, that's actually called amplitude. Like how far something swings like that is called amplitude. And so we were talking about chord or arc length as being a way to do that. Then we started talking about chord or arc length is going to be extremely difficult to measure for a pendulum. And then so someone suggested, well, maybe we could just measure the angle of the string. Brilliant. That seems like a much easier way to talk about amplitude, or how far the pendulum has been moved out of what we would call equilibrium or vertical. And so the angle might be a better and easier way to measure that. And so we said, okay, we can do that. We can measure that. Then we got to, it says the bottom swings farther than the top, meaning like at the end of the pendulum, it actually moves further than if you go further up the string. And that's true. And then we said, well, I mean, how exactly do you measure that? I mean, that's kind of what all this is about, I suppose. So then we got to the bottom moves faster than the top. And so we were talking about faster and how fast something is, and can we measure that? And I said, oh, I don't have a radar gun, so we can't measure how fast it's moving because we don't have a radar gun. And then someone mentioned, well, time, we can measure how much time it takes to go back and forth. And I said, sure. And back and forth is actually called one oscillation. And so I told the class that. And then I said that the time it takes to do one oscillation or complete one oscillation, that's actually called the period. It's called the period of oscillation. And this kind of motion of something that's repetitive, back and forth, it is called periodic motion because it repeats itself at regular intervals, which is why the periodic table of the elements is called the periodic table of the elements, because the characteristics of the elements, their properties, repeat themselves at regular intervals. If you were to list out the elements, those similar properties and characteristics repeat themselves at regular intervals. They are periodic, which is why the families are arranged the way they are in the table. Oh my gosh, that's periodic. Okay, anyway. So we said time would be something else we could measure. Okay. Then I asked them, okay, I said, what are some other things that might change how this, oh, hold on. Question number 2, can we change it without breaking something? Can you change how far it is from the equilibrium without breaking something? Yes. Okay, well, that works. And then we talked about time. the time it takes to oscillate once. Then I asked, is there anything else that we can change about the pendulum that might affect how it behaves? And someone suggested that the mass hanging on the string, which is actually called a bob, the mass at the end of a pendulum, a string that's swinging back and forth, that's called a pendulum bob. And so if you change the mass of the bob, could that change how the pendulum behaves? So the consensus was, yeah, it might. Can we change the mass without breaking something? Yes. Can we measure the mass easily? Yes. Okay, so that works. And then somebody else said, well, how about how long the string is? The length of the string might affect how the pendulum behaves. And I said, sure, that sounds good. And again, how about our filter questions? Can we measure it easily? Can you measure the length of the string? I sure hope so. Can you change the length of the string without breaking it? Why, yes, you can. So it looks like at this point, we actually had four different variables. We had the mass of the bob, we had the length of the string, we had the time of oscillation, and we had the amplitude. So there's 4 variables. Oh, you know what? Oh gosh, I may have to do this. There. Oh, but that blocking part, oh gosh. Anyway, because I know my image is down in this area here, and my picture in picture, and I don't want to block any important parts of the screen. So I asked, what are we going to do with these 4 variables? Like, what's the point here? What are we trying to find out? And the consensus was that the amplitude, the mass of the bob, and the length, all 3 of those, could affect how much time it takes for it to oscillate once. And so then we started talking about manipulative versus responsive variables, or independent versus dependent. And so we decided that the dependent variable, or responsive, would be time. That's what's going to depend on the changes you make with the length, the amplitude, and the mass. So those are the independent or manipulative. Those are the things you are going to manipulate. And then the time is the one that we think might respond to those changes. Now notice this right here. I have L or M or angle. So that's on the x-axis, and then time is on the y-axis. That's how we're setting up our graph. Something else that was suggested is that maybe we should have standard values for angle, length, and mass for the people, or when you're not changing the variables. So let's say, for instance, if you're changing the angle, then you should maybe have your length set at 75 centimeters and your mass set at 30 grams. So everybody that's changing the angle, these are the values for length and mass you should use. And if you are a person that's changing the length, well, obviously 75 centimeters won't be the only length you use. You'll be changing it a bunch of times. But you keep your angle at 45 and you'll keep your mass at 30 grams. Hope that makes sense. And then if you're changing the mass, well, then obviously 30 grams isn't going to be it. You're going to be changing it several times, but you're going to keep your length at 75 and your angle at 45. So these are like the control values for the variables that you're not changing, if that makes sense. Now, what I did is I asked each group in here to do one to examine and collect some data for one of those 3 variables. So that's what we did. We were collecting that data yesterday, which would have been Monday. So today is Tuesday, the day I'm recording the video. So they got that data yesterday. We're going to talk about that data on Wednesday. Now, if you would like, you sitting there at home, if you would like to, if it's possible even, if you have some string or a rope and something to hang on the rope, you might collect some data for this yourself. And you could choose mass as your variable, or length as your variable, or angle as your variable. And then try to collect some data. And again, the time is the time of back and forth to get back to where it started. So out and back is one oscillation, and that's the time you're measuring. So if you want to try to collect some of this data, at your home, and then bring that in, we can talk about all of that on Wednesday, because I think some of you are going to be back then. So anyway, that's what we did. I hope that kind of makes sense. So we went from circles to rectangles. Now we're talking about a pendulum. So hopefully I'll see y'all soon.